In this lecture, we will learn to interface with a 4x4 keypad. This will allow us to determine how microcontrollers can use few pins to be able to access input on multiple push-button based keypads. So we see keypads in a lot of places. Here might be a very typical example of where you would see a keypad. This is on an ATM. You might also see them in places like old simple feature phones. You might see them on keyboards, 4-function calculators. All sorts of interfaces use keypads, and they allow us to figure out with a small number of pins which button is pushed at any given time. So how can we interface with the keypad? Well, our goal is to figure out which key is pressed, so we could treat each of the keys as an individual push button. And to do that, we would basically just have to hardwire every key, just like a switch. We've already talked about how to interface switches with either pull-up or pull-down resistors. And so we could do that and use each pin individually. And if we did that approach for a 4x4 keypad, we would have to use 16 different ports because we have 16 switches. So there's bound to be a simpler way, and let's figure out how that works. So this is the schematic. This came with the documentation for the QL200 trainer kit that we've been using in this class. And you'll notice here that port C is connected to the keypad. These are the toggle switches that we have been using to determine whether we are using specific devices or not. Up to this point, we've left this turned off because we've not been using the keypad. For labs that will involve the keypad, you'll have to make sure that all of those switches are in the on position. And then you'll notice on here that each of our buttons in the keypad is simply a switch, a normally open switch, and when it is pressed, it closes. And so when that is pressed, what you'll notice is that there's a connection. So for example, if we press this line 4 right here is connected through this, and then is connected on down right here, and is connected down to there. So you're actually making a connection between this pin and that pin. And so you can see that there's a unique combination of connections between the upper bits here and the lower bits over there for each key press. And so here's how we interface. We can read 16 different keys using just 8 general purpose input-output pins. We're going to use port C for this purpose on the trainer kit. It's already hardwired to port C. And in the example code that we're going to be working with, bits 0 through 3 are going to be the outputs, and bits 4 through 7 are going to be the inputs. You could actually do this the exact opposite way. Really, our goal is just to figure out where the intersection is based on the switch, so you could send out signal one way and retrieve it the other way, and it doesn't matter which way you go so long as you're consistent. But you want to make sure block 0 through 3 are consistently either inputs or outputs, and then bits 4 through 7 as a block are the exact opposite. And what you're going to do is output a very specific pattern on, in this case, the columns, and you're going to check back to see what the input is to determine which row the key that is pressed is in, if any. And so we have to set up port C using tris-C as half inputs and half outputs, and what we're going to do is cycle through these 4-bit patterns. And you'll notice these 4-bit patterns are the only 4 patterns where there's a 0 in exactly one place and all the rest of the bits are 1. So you'll output 1 1 1 0, 1 1 0 1, 1 0 1 1, and 0 1 1 1. And then what you're going to do is look for where a 0 comes back on the input. And so if you have a 0 on an output, and then that's connected to your input, and you have a 0 on a specific bit of an input, the intersection of where you output that 0 and where you receive the 0 back will help to figure out which key is pressed. And so you can think of it as a coordinate grid where you have an X and a Y axis. And so your outputs help you to determine along the X axis, and your inputs help you determine along the Y, or vice versa. And so every time the output is changed, you want to check the input. If the input is 1, 1, 1, 1, then that means in that particular column there's not a key pressed. So you're going to cycle on and go on and check the next pattern and the next pattern. And if you get anything other than 1, 1, 1, 1, then you know something is pressed. Then what you need to do is look at what input pattern comes back in, and you can mask that off to determine which one of the keys is pressed. So you're just going to be looking for the zeros on the inputs. And we'll go through some example code that does this in the next video. So how do you display the result? Well, we've already learned how to send information out to 7-segment displays, and we've learned how to send information out to the LCD. So once you have figured out what you want to display, then you can go ahead and do the display the normal way that you've learned in previous lectures. And so if you're talking about displaying things on the 7-segment displays, you know you need to put a value into W, and in the code that we've been working with, you had a little lookup table to determine what value needed to go out on port D to determine which LEDs would be on or off in each of the 7-segment displays. If you want to put values out to the LCD panel, what you will want to do is also have a lookup table, but that will help you to translate from the numeric value into the appropriate ASCII value for the character that needs to go out to the LCD. And so we're going to go through in another video some sample code which will track which button is pressed, and it will display 0, 0 through 15 depending upon which of the keys is pressed. And if you don't have any keys pressed at all, it will output an FF. So look for another video that will demonstrate this. In the lab this week, you're going to combine what you learned about the LCD panel in a previous lecture with what you've learned about the keypad here, and you're going to learn to properly display a 10-digit phone number. And so you're going to put out an open parentheses, receive the next 3 digits. You're going to close the parentheses after 3 digits are received. Then you're going to output or wait for the next 3 digits to come in and output them onto the LCD, then display the hyphen, and then display the last 4 digits. And upon receiving all 10 digits, then you'll just display dialing on the bottom line of the LCD. So I hope you enjoy this week's lab, and we will have some in-class exercises this week where you will learn to perform some keypad functions. Hope you enjoyed.